So there's two formulas that you need to have for compound interest. Did I give you these formulas on there already? Yeah, I did. Okay. Now you can go ahead and fill in. What you may not remember is what the variables represent. So A is your ending amount. P is the starting amount. R is your rate as a decimal. N is the compound frequency. And T is time in year. So go ahead and fill those in. So the difference between these two formulas is that we use PERT, which is what I call this PERT, when it says compounded continuously. That's the key word. Compound continuously. If it's compounded with any other frequency, we use this calculator. I mean, not this calculator, this formula. So as far as calculators are concerned, if you don't have a calculator that can use a fraction, that will put a fraction in, you need to use one with a fraction. So make sure you have a yellow calculator. All right, so now let's talk about what these values mean. That one doesn't. I have to look at it.
Because I know there's apps.
Yeah, maybe that one. I don't know. Yeah, I can look at it at the end, but I will use the yellow one for now. Okay, so let's look at our different values. So for the first one, annually, if it says annually, and again, these values that we're talking about here, they apply to this formula. Okay, because if it doesn't say compounded continuously, we're using that first formula. All right, so if it says annually, that means that N equals 1. What do you think semi-annually means? Twice a year. What about quarterly? 4. Somebody usually says 25 because a quarter is 25 cents. That's pretty good. I'm proud of y'all. It's 4. Monthly, how many months are in a year?
12.
All right, here's the one. How many weeks are in a year?
52.
Oh, wow, y'all smart. And then daily, 365. And I don't have a lot of space to write that, so I had to write it above. All right, so let's go ahead and get started. Let's look at number 1. It says, if you deposit $7,000 into an account that pays 8.4% annual interest compounded monthly, how much money will be in the account after 4 years? So again, that is the formula we're using because it says compounded monthly. All right, so I like to write my variables down the side. You don't have to do that, but I like to identify what my variables are. So A is our ending amount, and that's what we're trying to find. Our starting amount is $7,000. Now the interest rate, we have to convert that to a decimal. So you're moving that decimal point 2 times to the left, which would be 0.084. So you're converting that percentage to a decimal. N is the compound frequency, and if it's compounded monthly, there are 12 months in a year. So N would be 12. And we want to know how much money is in the account after how many years? 4. So you need to very carefully, I'm going to write it the way you should type it. So it should be 1 plus, and then you're going to put the rate over N to the power of 12 times 4. Go ahead, type that in your calculator. You just have to get comfortable typing that in your calculator. It needs to look exactly the way I have it written. That's how it should look when you look at your calculator. Now, we're talking about money, so it should be rounded to the hundredths place. So 2 numbers after the decimal. Let's see my answer. So, all right, so this is what I got when I wrote it, when I typed it in my calculator. This was a while ago. I got $9,783.91. Raise your hand if you got that. Any questions? That's it. We just have to figure out, we just have to answer the question. How much money after 4 years? After 4 years, your 7,000 will grow to almost 10,000. All right, any questions about number 1? Let's look at number 2. It says, if you deposit $5,000 into an account that pays 2.9%, now we notice that it's compounded continuously. So now I'm using PERT. How much money will be in the account after 10 years? So again, we're trying to find A. We started off with $5,000. My interest rate would be what? How do you convert 2.9% to a decimal? 0.029. Yep, 0.029. And how much time are we leaving this money in the account? 10 years. So in your calculator, now we're using that E. So you have to hit second function ln. So the ending amount will be 5,000. And then you're going to put that E. Now you may have to, every calculator is different. You may need to put this in parentheses, or you may not. Just make sure that it's in, both of those numbers are in the exponent. I wrote on the board what someone's going to say.
I forgot, my bad. You know it's a Wednesday.
All right, anybody brave enough to say what they got?
I got.
What'd you say? I didn't hear. I heard. What'd you say? Can you say that one more time? $6,682.14. That's what I got. Anybody else get that? All right. So far, so good. Let's keep moving. Go ahead and try to do this one on your own. So now we have $3,000 into an account paying 6.1% annual interest compounded quarterly. How much money will be in the account after 9 years? So I'm thinking, because these are pretty easy. The only mistake that I noticed as I'm trying to think back over the years of teaching this class is that students forget to convert the percentage to a decimal. So the one thing to keep in mind is that you shouldn't get like, if you can't go from 3,000 to 2 million. So if you get a number that's abnormally large, it's probably that you did not convert the percentage to a decimal. That's really the only mistake that I can think of that has been made a lot in the past. So we're going to just type this in our calculator. Okay, Jim Quayle, you want to tell me what you got?
No, because I actually did 2 instead of 9.
Oh. You want to tell me, Ava?
Wait, if you give me
5,000. 0.7? 0.07 or 0.08? 0.08. Any questions about that? Yes.
Are we always trying to find A?
Nope. So now let's move on to example 4. Once, yeah, that was a good segue. Okay, so now it says we have 2.35% annual interest compounded continuously. Now it's asking us to find how long. So what variable are they asking us to find now? T. We're trying to find time. Notice that they did not tell us the start and the end. That's because it doesn't matter. Okay? It doesn't matter what you use to start. So I usually just use $1. If they don't tell me, then I'm going to say I started with $1. So if I'm trying to double it, what would I end with? $2. Now, do you have to use 1 and 2? No, you can say you started with 5 and ended with 10. You can say you started with 100 and ended with 200. You can say you started with 50 cents and ended with $1. If they don't tell you and they're asking you how long it takes to double, you pick the start and make sure the end is double that. And then the interest rate is 0.0235. So this is why I like to use 1 and 2, because we're going to have 2 equals, and see how that 1 just becomes invisible? 0.0235 times t. So I'm dividing both sides by 1. We don't have to worry about that. How do you cancel out e? What is the opposite of e? ln. So we need to put in a natural log. When I put in a natural log, I'm going to erase this 1 because I want it. That cancels out the e. So now this exponent is no longer an exponent. It's now down. So what we have is the natural log of 2 equals 0.0235 t. And what's my last step to solve for t? Divide. Both sides by your interest rate. So go ahead and type that in the calculator. Take the natural log of 2 divided by 0.0235. Just make sure when you take your test next Wednesday that you look at the rounding position, because it's going to vary. It could say rounded to the tenths place. It could say rounded to the thousandths place. For this one, I rounded it to the tenths place. I only gave 1 number. So, and because it's such a low interest rate, okay. So what did you all get for T?
29.5.
And what's our unit? What did we say T is measured in? Years. That's a long time to double your money, but that's a pretty low interest rate, so that would make sense. We're going to finish this today, y'all. Let's finish it. See, we don't need extra time. We're going to be done today. What are we going to do? I may give you the study guide tomorrow. Okay. So now we got Nevaeh. This is a two-part question. First, we need to figure out how much money is in her account after 9 years. So you're going to try to find A. And then we need to figure out how long it's going to take her to double her interest. So this is a two-part question. So go ahead, find part A. That's the easy part. It's compounded monthly. So what does that mean? N is going to be 12. I didn't really give myself a lot of space. Just as a little hint, I got something between 7,000 and 8,000. So your answer should fall between 7,000 and 8,000. Okay, so I got, let me go ahead and unfreeze my screen. $7,669.38. Who had that for part A, for the first part? Okay, good. So now we need to figure out how long it's going to take her to double it. So if we started with 5,500, what would my ending amount be if I'm trying to double it? What am I going to do with that 5,500? 11 bands. Multiply it by 2. So now we're trying to figure out the time. So we're trying to find T. This is what we're trying to find here. So let me go ahead and write that. A, P, R. Let me go ahead and wipe this out. Oops, sorry. N, and we don't know T. T is what we don't know in part 2. So we know we're trying to double it. So we multiply the start by 2, which gives us 11,000. We're starting with 5,500. The interest rate is still 3.7%. And it's still compounded monthly. All right, so let's go ahead and put everything in this correct position. So I have $11,000, or 11,000 equals 5,500. 1 plus, and then 0.037 over 12. And then it's 12 times T. So that's what I don't know. So the first thing we're going to do is divide both sides by 5,500. And that's where we get the 2. So we get 2 equals, and then I have this parentheses. Okay, so here we are. We got 2 equals that. So now we have an exponent. This is not as easy as the last one because we don't have a log that has a base that's this complicated. So it doesn't matter if we use a common log or a natural log. Either way, nothing is going to cancel. So which one do you want to go with? Natural log. I heard somebody say that. So let's go ahead and put an L in and an L in. By putting in that natural log, that's going to move this to the front. Because remember, that's what the log property says. If you have a log and then you have a base that has an exponent, the property tells us we can put that in the front. So now we have the natural log of 2 equals 12t. And then I have the natural log of this big parentheses. All right, we almost there. Now, I want you to keep in mind that these are being multiplied. This is a number. This is a number that I'm multiplying by time. And so is this. This is a number. So I got to divide both sides by those two things that I have highlighted. So this is really kind of complicated, but you have to take your time. What you're going to type in your calculator is the natural log of 2 divided by 12 times the natural log of that parentheses. So you're going to have a fraction and a fraction. And yes, the calculator will do that for you. That is how you want to type it in, just like that. So go ahead and practice doing that. What'd you say? Can you say that one more time? Yeah, how do you put it in there? Wait. Oh, yeah, this is the space is confusing you? So that's like a little multiplication sign right there. Yeah. You just you don't have to separate it. Oh, you mean right here? How do I separate these two? So this is kind of like saying, what if you had 3 equals 5 times x times 2? You can divide both sides by 5 times 2. So even though they're on opposite sides of t, they're still being multiplied by t. So I can divide it. You can divide a number by two things.
Because it's still 12 times t.
I'm so glad. I can't do him no more. I'm going to leave him to Miss Glaze. What'd you say again?
Because it's still 12 times.
Yeah, it's 12 is being multiplied. I mean, t is being multiplied by 12 and by the natural log of that big number. So in my opinion, this is the only one that's kind of difficult to do on the test. So, but the calculator, if you type it in correctly, I did. I got 18.8 years.
Yeah.
Is that what you all got? Yeah. All right, type it in again.
So if it doesn't say what it wants us to round it to, you just want us to do just
Yeah. But I'm going to make sure that every question on the test specifies it. All right, we're going to end there. We're going to finish this last one out tomorrow. You can do most of homework 22. So go ahead and get that started.
So that's
Homework 21 is due Friday. Yeah.